Okay, now I will talk about graphical interpretation of average velocity. You can find this in the text in page 24 and 25. Yes, we will use a graphic representation for position with respect to time. We have the time in seconds, not in meters. Okay, in the XY plane mathematics, this is XY plane. As I talked before, in physics, we can use the x-axis to represent the time, and we can use the y-axis to represent the position. Okay, the positions here in meters, but the time in t, the dimension of time is t in seconds. Okay, you need to understand and to know that the body is not moving through this track, along this track. It will not come in this way. If we put in this way, in this direction, we can see that this is x direction, positive x direction, and this is the negative x direction, and this is the time axis. We can name the positive x direction as right direction. Also, we can name it east. We will see that in many examples or questions. Also, the negative x-axis, maybe we name it left sometimes, or west. And the positive y direction, we can name it positive y, or north, or upward, if we are working with just two dimensions, and the same for the negative y direction. But now we are working with time. We don't have positive and negative time in this example. Okay, at t equals 0, this is the time. At t, this is time equal 1, time 2, 3 seconds, 4 seconds, so on. At t equals 0, the position of the body is 0. At t equal 1, the position of the body is here, so the body is moving right. At t equal 2, the position of the body is here, the body moving also right. At t equal 2 point, you can estimate that point. It is a returning point for our body. It will come and reverse its motion. At t equal 3.2 or something like that, the body reaches the origin again. Then it starts moving in negative direction, negative x direction. At t equal 4 seconds, the body is at minus 18 meters, and so on. Also, the body returning point in x, in left direction or west or negative x direction, it is at t equal 5 and something more than 5. The returning point is about minus 36 meters, and so on. Now you can see that through or within from 2 seconds, from 3 to 5, the body passes almost 36 meters in negative direction, or in left or in west. In 2 seconds, from 3 to 4, from 4 to 5, it passes these it changed its position from 0 to negative 36. But from 0 to 2, almost, it changed also its position from 0 to 6 meters. So it spends 2 seconds to move to the right 6 meters, but it spends 2 seconds to move to the left 36 meters. We have changes in velocities during its motion. How can we compute these velocities during these times? It's easy. We know that velocity or speed is equal to x final minus x initial divided by t final minus t initial. We can use any x we need and any time we need to calculate the velocity, and that's what we will do now in our examples. Okay, for this sheet we can start. This graph represents object's motion in the x direction. Assume that the positive direction is in the positive x-axis. Okay, find the average velocity during the times or between from t equals 0. This is t equals 0. This is t in seconds. This is t equals 0. I will use a different color, yes. And t equal 5 seconds. This is t equal 5 seconds. Yes. At t equals 0, I have t equals 0 and x تساوي 0. At t equal 5, the body is here. T equal 5 and x equal to minus 36. I can use this as t initial, x initial, t final, x final. What is the velocity? I can compute now the velocity, because not the speed, because I know the directions. I know that the positive direction in the x positive and the negative direction in the x negative. Okay, so the velocity is equal to x final minus x initial divided by t final minus t initial. From where I reach this formula, I know that the rate of change of the position is the velocity, okay, which is equal to x final minus 36 minus 0 divided by 5 minus 0, which is equal to minus 36 over 5, which is equal to 7.2 meters per second, but with minus sign. The minus sign means that the body is moving in the negative x direction. Is that clear? Okay, I calculate the first velocity. I need you to remember this point. If I have a function y is equal to f of x, I can find the slope is equal to y2 minus y1 over x2 minus x1. In my case here, I really find the slope. Look, I can draw a line between the 2 points. I will make it easy to be seen. This line is going down. That means its slope is negative, and that is what I find. Also, how can I know that? If I move to the right in time, or if I move forward in time, then that position going down. That is the meaning of the negative slope. Now I will find the next one. The next one, I have t initial 1.25. 1.25. This is 1. This is 1.5. This is 2. 2.5. This is 1.25. X at this point almost is equal to 2 because this is 2, 4, 6, 8, 10. It is easy to be understood. This is my initial point. I have at it t initial is equal to 1.25 seconds and x initial is equal to 2 meters. Okay, what is the second point or the final point? It is at t equal 3. At t equal 3, this is t equal 3. I have this point, the final point, t final is equal to 3 seconds, and x final is equal to the same value, 2 meters. Now I need to calculate the average velocity. Velocity is equal to x final minus x initial over t final minus t initial, which is equal to 2 minus 2 over 3 minus 1.25. 2 minus 2 is 0, so the final average velocity between one initial value and final value is 0 meters per second. It is velocity and it is a vector because I'm talking about velocity. What is the meaning of that? Is the meaning of that the body is stationary? No, between these 2 points, the body was moved from this point to this point, but the position or the change in the position is 0 because the body is going away to the positive direction and then return to the same point. Okay, in this case the velocity is 0. You can find the velocity for these 2 points. One of them between 3 and 4. You will see that the velocity is negative. The next one is between 4 and 5.5 seconds and 6 seconds. This is 4.5. This is the point. You can approximate it. And 6, which is this is the point. You can approximate it. You will find that the slope in this way will be positive slope and the velocity will be in positive direction. Now I need to talk about another thing, which is instantaneous velocity. It is easy to be understood. The instantaneous velocity is the velocity at a certain point, at a certain time. Okay, what does that mean? If I look at the time t equal 2.25, this is the time, 2.25 seconds. I need the velocity at this point. How can I find that velocity? I don't have v initial and v final. I have just a point. In this case, I can't draw a line to find its slope, but I can find and draw a tangential line. Look, you have and you can draw this tangential line in this case like this. It is horizontal one at this point. The slope of the for the horizontal line is 0. I can find that. How? The velocity is equal to x final minus x initial over t final minus t initial. Okay, I can pick any 2 points. I will take the first point, the second point at t equal 3, at t equal 4. This is 1 and this is 2. I have the position at t equal 3, x initial, and here is x final. So this will be equal to x final, which is 6, minus x initial, which is the same point 6, because my tangential line is horizontal. Okay, the change in time t final is 4 minus 3, which is the initial time. This case I have 0 meters per seconds. For this is the slope of the horizontal line. Okay, I will take the next one at t equal 3. This is t equal 3 and this is the point. I will not suppose that I need to use this position. I need to again here to draw a tangential line at t equal 3. The tangential line, I suppose it to be tangential. Maybe I will have some errors in drawing this line, but that error will not be that different between person to another person. Maybe you will draw it like this or like this, but the change will be not too much. Okay, this is the tangential line at t equal 3 approximately. Now I need to choose 2 points. I will choose this point because it is easy to know how much the time and how much the position. If I choose this one, it is difficult to find the time here. If I choose this one, it is easy to find the time. It is 4.5, but it is difficult to find the position. So I search to find any 2 points, easy to pick the time and the position. Easy to pick to find x coordinate and y coordinate. I find this one. I will take it as t final and x final, and I will find look. I can choose this one. I can take it here, t initial, x initial. Okay, t initial, it is 2.25. X initial is 10 meters. This in seconds. Okay, here t final is 5 seconds. X final is 20 meters. Okay, I can now calculate the velocity. Velocity is equal to x final minus x initial over t final minus t initial, which is equal to x final 20 minus 10 in meters divided 5 seconds minus 2.25 seconds. I can put meter here and here, but that will be sometimes difficult and knowing. Okay, this will be equal to 10 over 2.75, which is equal to meters in seconds. Where is this? 10 over 2.75 is equal to 3.63 meters per second. But look, I have an error, a mistake now. How much the position here? It is not 20, it is negative 20. Negative 20. I'm sorry for that, but that is good to make mistakes to learn better. So this is negative 20 and this is negative 20. In this case it will be 30, not 10, 30. So the final result will be not 3.63. The final velocity, the average velocity will be 10.9 meters per second with negative sign. The negative sign means in negative x direction, or in to the left, or to west. I don't prepare for this mistake. It happened with me, it will happen with you, but be careful that we have positive direction and negative direction. Be careful to take another look to your solution. Also, how I find this mistake, I look to my line, I saw that this line has a negative slope, so my solution at first time is wrong because I have it positive. Then I can correct my mistake. Is that clear? Now the third point at t equals 6. This is t equals 6. This is the point. You can draw that tangential line like this, which has positive slope and positive velocity, and you can pick any 2 points and find the velocity in this case. Thank you.